Okay, let's come to the last type 4, where a single function that cannot be integrated directly. Just a simple example. Example 18. Let's take a look at ln x. Obviously, ln x cannot be integrated directly. So what do we do? It's difficult because if you've never seen this technique before, it's hard to think of it, but once you see it once, you realize that it's part of your repertoire. You should be able to handle it. Now, integrate ln x, you can see it like as if it is integrating 1 to 2 1 times ln x. So we just create a 1 times. So now we can, instead of one function, now we have two functions where one of it is 1 and the other is a ln x. So which one do you differentiate? Which one do you integrate? Quite easy. Let's recall again. Ik minus integrate id. One of it you have to differentiate. One of it you have to integrate. Now we obviously don't know how to integrate ln x, so we have to differentiate this. And we have to integrate this. So let's recall again. So integrate 1, I get x. Differentiate, keep, of course, I get ln x minus I. So, but then let us not forget this is an integration with limits, right? With limits 1 and 2. So we enclose it. All right. Minus integrate 1 to 2. ID, right? ID. So integrate, I'll get a x. Differentiate, I get 1 over x. Yes. Correct? And of course, it's not difficult to see that this is actually equals to 1. So integrate 1, I get x. So this, the answer is done like that. Okay, integrate this 1, integrate 1, I get x. So x from limit from 1 to 2, and I get answer. That's it, easy. Okay, let's take a look at 18. Example 18b, slightly trickier. Again, I have a single function. Alright, so no prizes for guessing. Is 1 multiplied by sine. So we will obviously differentiate this guy and integrate this guy. Okay, so if you do that, let's follow the steps. And k is easy, keep, minus integrate now the d is slightly trickier. You differentiate this, you get a cosine ln x. Correct? Let us not forget chain rule. I must differentiate ln x once. I will get 1 over x dx equals to x sine ln x. And then you realize that x times 1 over x, you get 1. Then you will get integrate cosine x. Then you tell me, oh, not very good because I still don't know how to integrate this expression. Integration by parts is lousy. Remember what I said. Look, if by parts doesn't work one time, you would suspect. I'm not saying it works all the time. You would suspect that you have to try more than once. And because sine x, cosine x, when you repeatedly differentiate, it's cyclical. So you would suspect that if I do it one more time for this guy, I will get back sine x. Never mind. It's okay. We try. Okay, we try. That means we're going to do by parts one more time. So which means I get an x sine ln x. I keep this guy. Minus, I enclose it in a large bracket. Again, I do IKID again. I'm not going to write at 1 times, but you know what I mean. Which is integrate 1. Maybe I can just create a 1 here. Alright. 1 I k, keep this is easy, minus integrate I d. Correct? Let's differentiate cosine. Differentiate cosine, I get a minus sign. So let's not forget our minus sign ln x. Again, I must have a 1 over x because I actually differentiate ln x once. Chain rule tells me that. Dx, and then close the big bracket. Yeah. So let us remove this big bracket. This one clearly remains minus x cosine ln x. Look, this is a minus, minus become plus. So times another minus, it's minus. So minus integrate. And of course the x and 1 over x becomes 1. Becomes a minus sine ln x dx. Oh, then you tell me, hey, another integral that I don't know how to evaluate, but let's take a look. This is our left hand side. Sorry, this is our left hand side. This entire thing is our right hand side, which has a repeated expression here. So let's recall how to solve u equals to 1 minus u. Correct? Correct? This is u, the right hand side is u. Not difficult, 2u equals to 1. So what we need to do is to then bring this u across. We will get the answer. So therefore I have 2u equals to this entire expression here. Alright? Yep. So I'm just going to put it here. And just for completeness, there should be a plus c, because whenever you do an integration, there should be an integrating constant. All you need to do is divide both sides by 2. We will get the answer. Correct? Divide both sides by 2. Here, we get the answer. Now you get c over 2. You can put it as d. Doesn't matter. And we're done. Right? Yep. Not difficult. Okay. Just as a quick summary. Now, very often you see an integral, and then you see a product of two functions. You ask yourself, which one do I differentiate, which one do I integrate? Now, the type 1 to 4 actually serves as a good guide. Just as another guide, you can apply this heuristic LIATE. We all like acronyms, but must know what it means. Let's take a simple example. Let's say I want to integrate x ex. Just as an example. Now then you ask yourself which one to differentiate, which one to integrate, but by now we all should know that we will differentiate x. Alright, we will differentiate x and we will integrate this e to the power x. Now this heuristic will help us to decide which one to differentiate easier. So look, if you write it out like that, L-I-A-T-E, the higher it is, the more difficult it is to integrate, therefore you choose to differentiate. Okay, I say again, the higher it is, you choose to differentiate. So you look at it, this x is an algebraic function. This e to the power of x is an exponential function. So if I may write down, this is x. So the higher it is here, you will choose to differentiate. The lower it is, you choose to integrate. Just as an example. So we all know what it means. So let's see what it means. Log, of course, example, ln x. Alright. Inverse trigo. Let's take a look. This is I inverse trigo, which means that is your arc sine, arc cos, etc. Algebraic, no prizes for guessing. X square, x cubed, trigo is your sine x, secant x, Exponential is e to the power x, 2 to the power x, are all exponential. Okay, so again, I will say again, the higher it is, you will choose to differentiate. Can I just emphasize that this is a guide? Don't take it like ultimate fact. It's not a rule, it's not a theorem. It's just a guide. There are certain exceptions. You can play around with this and you realize that it doesn't quite work like that. Alright? Okay, that's the end of the chapter. Thank you.